Hello guys, this is CodeNCode and this is video editorial for the problem find median from data stream taken from Leetcode top 100 like questions. The problem is rated hard difficulty level, and we will be solving this using min-max heap. The problem statement is you are given a stream of data. That means you will be given input one by one, okay, and we are given two functions, that is add node and find median, that we have to complete. Let me just show you. Here it is. Okay, so we have add number and then find median, and of course the work of add number is to add number into your list, and find median, when called you need to return the median of the list that currently we have. Okay, and if you are not able to understand it theoretically, let's take an example. So this is your test case. Initially we don't have any number, right? So suppose add number was called, so in our list now we have 5. Again add number was called, so now we have 5 and 7 in our list. Now find median was called. So if you do not know what is median, if in your input data, if in the data you sort it, if it has odd number of elements, then take the middle one, that will be your median. If it contains even number of elements, for example in this case we have 2 number of elements, then take n by 2 and n by 2 plus 1th element, that means the first and the second element, take their average. So first and second are of course 5 plus 7 divided by 2, that is 6. Okay, so median of this data is 6. Now suppose the next query was made to add number, so now we have 257, okay, in our list, and now median, what will be the median? Again you can see the number of elements are odd, so middle one will be the median, that is 5. Okay, so this is what we have to achieve. We have to complete add num and we have to complete find median, okay, in such a way that we are able to add element and print the median, and we have to do it efficiently so that we don't get any of course we don't get TLE. Now important thing is that the input is actually not sorted, and that is where the problem begins. If it was sorted, we would have been able to solve the problem easily, but the input is not sorted, so we have to figure out how we can solve this problem. So to solve this problem, you need these prerequisites. You should be comfortable with any programming language. You need to have the knowledge of min-max heap. In C++, you need to have the knowledge of STL, in which you can learn about priority queue, right, using which you can implement min and max heap, and of course very basic knowledge of number theory because of course median, right? These are the only prerequisites to solve this problem. Now how we are going to solve this problem, let me give you a hint, an idea where you can begin forming your solution at. Okay, so suppose at certain point this is your input. Okay, again the input is not sorted. Just assume after certain number of operations this is your list of integers. Okay, so what you can try to do is try to divide the elements in upper and lower half, okay, and try to see if you are able to solve this problem. Okay, you have after certain number of input, you have certain number of integers. Try to divide them in upper and lower part. After that, try to figure out how this can help you solve the problem, because that is exactly what we are going to do. Using this same approach, we are going to solve this problem. Okay, now are you a student or a working professional who is looking for great career in software development? Then you have to think about aspects like what's trending in the industry and what kind of questions are being asked in interviews. What's the thought process behind the architecture of great applications like Google, Amazon, Zomato, etc., and how you can improve your CodeChef ranking. Show hosts on Unacademy are working with some of the top companies like Google and Amazon, to name a few. They are 7-star coders on CodeChef and are industry experts with years of experience. They'll walk you through their own industry experience and interact with a lot of guests like HR and industry leaders of top companies, where they will ask questions raised by you. The shows will be covering a lot of content that will benefit your career. Like in live episode, you get an opportunity to ask tech HRs about top 20 interview questions and industry leaders directly about their recruitment process in startups and MNCs, what's their eligibility and how to apply, and how they build such great products. Even get your resume and your college or personal projects improved by getting them reviewed by expert SDEs. And not only this, you can participate in mock interviews and learn courses on programming languages, cloud computing, blockchain and crypto, tech aspects of digital marketing and data analytics. In this show, Ajay will be unlocking one's potential for web development, right from the introduction to building one's career in web development. The show would also cover some HR tips and tricks during web development interviews, the pros and cons of a career in web development, and what are some upskilling opportunities one should be taking up throughout their careers. So what are some of the differentiators that you'll find here but not on YouTube? Of course, hear directly from companies, their HR and tech teams on what they look for in individuals while acquiring people. Also, get your questions answered directly from show hosts and your HR guests. And not everybody needs to pay a lot. You can get your daily dose of learning and many such shows at price of $999 for an entire year. And you can use my code CodeNCode_UA and get 10% off and get the same subscription at $899. So now let's get back to our lecture. Now here you can see I've divided the array into two parts, lower half and the upper half. Okay, just to remind you, we won't keep this. We will only have two data structure of some kind, of course min heap and max heap, such that one of them will be keeping the lower half and the other one will be keeping the upper half. Okay, we won't have this one. So now if we have lower half and the upper half, can you answer this question, what will be the median? Well, you might have guessed it. The median will be the upper element, the biggest element of the lower half, and the lowest element of the upper half. Oh yeah, it depends on whether the total number of elements are even or odd. If the number of elements are even, for example in this case, since the sum of lower half and the upper half is going to be even. Okay, so clearly we will have two elements. So biggest element of the lower half and smallest element of the upper half, average of these two, right? That will be your median. Now again, important thing, the lower half and the upper half, of course, since the name is half, either both of them will be having equal number of elements if the total number of all elements are even. Okay, for example, if I have 14 elements, these two will have 7 and 7, right? The second condition is that the total number of elements are odd, for example 5. In that case, our lower half, this is our assumption, this is going to be this you will be defining the way you are going to solve this problem. Okay, I have defined it this way. I'll keep extra element in my lower half. Okay, if you are going to solve it other way, it depends on you. You can also keep extra element in upper half. Okay, so if I have even number of elements, my lower half will have one extra element as compared to my upper half. Okay, so now what will happen if we have odd number of elements? As I have already told you, now my lower half will have one extra element and my upper half will have one element less than the lower half, right? Now in this case, when you know that their sizes is not equal, that means we have total number of odd elements. Okay, if we have total number of odd elements, what will be my median? Can you guess? Well, you guessed, I mean most likely you guessed it. It will be the biggest element of lower half, right? Because this will be your n by 2 plus 1th element, because we have like 7 elements. 7 divided by 2 is 3, 3 plus 1 is the 4th element, which is 10. So this is going to be our median. So in that case, if the lower half and the upper half are not equal, in that case your median will be the biggest element of the lower half. If both of the elements are equal, then in that case just take the biggest element of the lower half, smallest element in the upper half, and take their average. Okay, now the question is how to maintain this. Okay, we are not given simple input array, so we can't do this. So how to maintain this? For that let's make some observations. Now one important thing, at this point we are only interested in the biggest element of the lower half and smallest element of the upper half. So just keep in mind, right? Just keep that in mind. We are going to make decision which one is going to be max heap and which one is going to be min heap, because here we are only interested in the biggest one, here we are only interested in the smallest one, right? So keep that thing in mind. Now let's see how to decide, I mean how to keep these two intact. Okay, how to build these two, you can say. So suppose at certain point you already have lower half this and the upper half is this. Okay, and the new element comes. How would you decide, or how would you make it? Let me just give you an example. Okay, so suppose you already have lower half this and upper half this. Okay, we already discussed if the number of elements are odd, lower half will have one extra element. Okay, so this was the input at this point. Up until this point we have this input, and so lower half is this, upper half is this. Now can you decide where will 9 go? Will it go here or will it go there? Just keep in mind, after this addition this will go somewhere either in the lower half or in the upper half. So after that, either these two should be equal, or this one should have only one extra element than this. Okay, so keep that thing in mind. So decide where will it go. Of course, since the biggest element of the lower half is 10 and 9 is smaller than that, so this must go somewhere in between there, right? So this should look like something like this: 3, 6, 7, 9 and 10, and the upper half will be like this. But again, this one now contains 5 elements and this one only contains 3 elements. So clearly we need to make some transitions, okay, some changes. I need to make some element from here to go there. Which element will go from here to here? Can you guess? Of course, the biggest one. Again, we are only interested in the biggest element of the lower half, remember? So what I'll do, I'll send the biggest element here. Now again, what is the condition to add an element into the lower half? The condition is that the element should be smaller than the biggest element of the lower half. So again, we are only interested in the biggest element of lower half. That means lower half is going to be our max heap, okay, because we are not interested in these elements. Okay, and same goes for the upper half. For upper half, we are only interested in its lowest element, smallest element. So upper half will be represented by our min heap. So if I show you the code, I have two heap, min heap and max heap. Okay, we have already covered how to create min heap using priority queue in C++ STL lecture series, right? So now what we are doing is that if the top of the max heap, that means this, if the top of the max heap, this is our max heap, remember, if the top of the max heap is actually greater than the element, right, this one, then what we'll do, we have to transfer one element from the lower half to the upper half, right? And that's why in min heap we'll push the top of the max heap, right? So basically we are, even before I am inserting 9, I am simply transferring 10 to the min heap, and that is exactly what is happening here. I'm transferring top of max heap to the min heap. After that, remove that element, and after that you can add the current element into the max heap, as simple as that. And what will happen if you wanted to add something like let's say 15 at this point? If here we had 15, what you will do, 15 is clearly greater than this, so 15 will not go here, okay, so it will directly go here. Since the sizes of these two were already being differing by 1, so when you add an element here, they will become equal, and that is supposed to happen, right? So otherwise, that means in the else condition, you could directly add the current element into the min heap, as simple as that. Okay, so just try to think what will happen if both the elements are having equal number of elements, right? Here we covered if both the elements are not having equal number of elements, we covered that. Here you see if both of them are having equal number of elements, so if condition. Otherwise, this is when they don't have equal number of elements. So this we covered. Let's cover this. Okay, now keep in mind one more thing. Since the element, both lower half and the upper half are having equal number of elements, that means when you, after you add new element, the lower half will have one extra element, right? It is possible that either this element directly goes here, or this element goes into the upper half and the lower element shifts here, right? So now let's see. So what should be the condition to add this element here? Well, if the current element is greater than the lower, the minimum element of the lower half. Basically, if this is greater than 10, right? If you are adding any number 11 or greater than that, you have to add it into the upper half, right? So if the current element is greater than the minimum of the upper half, that means if the current element is actually greater than the top of the min heap, that means you have to add that element into the min heap. But if you add that element into the min heap, that means your upper half actually contains one extra element. That is wrong, right? And to cope with that, what we'll do, we'll shift one element here. So that is exactly what is happening. If the current element is actually greater than the minimum of the upper half, that means you need to remove one element. And which element you will remove? Of course, the lowest element in the min heap, upper half, right? So the lowest element you can get by the top of the min heap, so that will be transferred to the max heap, and you need to remove that element from the min heap as well. Okay, and after that you can add this element to the min heap, current element to the min heap. Basically, if I had 50 here, what I'll do, I'll transfer or shift 10 here into the lower half and remove 10 from here, now I am only left with two elements, 17 and 21, and add 50 to the upper half. As simple as that, right? And otherwise what will happen if that is not the case? That means the number is not actually greater than the smallest element of the min heap. In that will, what you have to do in that case, this element is not going into the upper half, this is going directly into the lower half, and you can directly insert it there. As simple as that. And now when you start, your lower half and the upper half will be empty completely, right? So if they are empty, that means the size of the max heap, which is the lower half, if this is 0, that means both of them are actually empty. In that case, you can directly insert the first element into the max heap itself. Again, as I told you, when we start, our min heap and the max heap, this is max heap, sorry, max heap and the min heap both will be empty, right, when you start. So if the first input was 3, this should go here. Why? Because again, as we discussed, I'll keep max heap and min heap in such a way that max heap may contain one extra element, but min heap will not. Okay, so if both are empty, that means their size is equal. In that case, the new element will go here, right? And that is this condition. If both of them are empty, the first element that we are going to insert, I'm directly going to insert into max heap or the first half. Okay, so yeah, this is how you complete the add num function. I'll be providing this link, this solution in the description of the video, so don't worry about that. And when you have to find is as simple as that. If they both are equal, that means we have even number of elements. So what we'll do, we'll take the max of the max heap and min of the min heap, basically top of both of them, and divide by 2. Basically we have to take their average, right, and return it. Otherwise, if their size is not equal, that means we have odd number of element. In that case, you can directly return top of the max heap, right? As simple as that. So yeah, this is the solution. If you still have any doubt or query, you can ask in the comment section. So yeah, this was all for this lecture. Thank you guys for watching, and until the next video drops, keep coding. Thank you.